This program is brought to you by the University of California, Davis on iTunes U. For more information, please visit us at itunes.ucdavis.edu.
Welcome to the key points for Lecture 3. Today we talked about sediment transport in class and talked about bed load transport, which are grains that roll, and saltate, and suspension transport. One of the key points is the effect of bed shear stress on lifting and moving grains in bed load transport. So those are the issues I'm going to highlight right now. So here I've drawn the depth of the flow and the flow velocity, and the velocity is shown in orange. We have the boundary layer where the flow is slower due to friction with the bed, and the brown circle represents a grain. And as you can see from the grain and the flow speeds, the force at the bottom of a grain is very low because the flow speed is low, whereas the flow speed is much higher at the top of the grain, so you end up with a force pushing the grain downstream at the upper end and also in the middle of the grain here. And those forces tend to make the grain roll. So you have a differential force on the top and the bottom, and the grain tends to roll downstream. Grains that roll are part of the bed load transport, and those grains are said to be in traction. Okay, so the second part of traction load are grains that saltate or that are lifted off the bed. The Bernouli effect is a pressure difference on grains on the bed, and when the pressure difference from the bottom to the top of the grain is high enough, the grains get lifted off the bed. So if we look at an example, we have a flat bed here and a grain. Gravity pulls down on the grain and holds it down on the bed. So we have the force that's related to gravity, which is related to the mass and the gravitational constant. And then the difference in pressure on the grains comes again from the difference in flow speed. Water is flowing very fast across the top of the grain, and that leads to a relatively low pressure at the top of the grain than down at the bottom. Where the flow speed is very low, you end up with lots of collisions on the grain, creating that pressure. Also, the flow is moving into the grain from the upstream side, creating high pressure here, and then the stream lines come down around behind the grain, and you have a low pressure area on the downstream end. So the Bernoulli effect is related to these pressure differences on the grain. Sum up those pressure differences, the net force from the differential pressure is downstream and generally up. So here we have pressure. So if the pressure, the upward force component of the pressure difference is larger than the force pulling down for the grain lift up off the bed. And that is basically the effect. And of course, the key components about which grains move depend on their density and their size, and the difference in flow speed between the bottom and the top of the grain. And because of that difference in flow speed, that relates back to the Reynolds number and the boundary layer conditions. Oh yeah, and I forgot to say, thanks for watching.
The preceding program was brought to you by UC Davis on iTunes U. Please visit us at itunes.ucdavis.edu.